Waiting for Scotty. All right, we're live on Facebook now. Welcome in to Leupold Live. My name's Nick. We haven't done one of these for a while, so we had an idea cooking where we're like, can we do a live from the shop floor? And we pulled it off. So we are live from the shop floor where we're making parts 7 days a week, almost 365 days a year. I really wanted to show you guys what happens here on the shop floor. We're going to talk about a lot of the precision that goes into manufacturing the parts, show you some of the internal parts, pull back the curtain a little bit, and really show you what makes Leupold different from other optics manufacturers, right? So thanks for joining us again. Make sure to type your questions also. So I have a guy over here. He's typing questions. They're going to pop up on my screen. You guys submitted a ton of good questions last night on Instagram. So I already have like 30 questions, really good ones here to run through. So we'll definitely get to those. But before that, I want to introduce Mr. Bill Sands here. So Bill is our Senior Manager of Parts Manufacturing. So tell us a little bit what that means.
So all the components that go into the scope that are manufactured here in the United States, we produce them right here in this building.
Right.
We have about 450 people in the manufacturing out of 700 people.
Yeah.
200 of them are on the part side.
Yeah.
And 100 machinists, very talented machinists.
That's awesome. That you heard that right? You say 450 people here on the parts manufacturing side?
In manufacturing, including assembly.
That's when we talk about how complicated a scope is and how many parts go into it. It does take that many people to do it right, like we do it. How long have you been here, Bill?
I'm the new guy. I've been here for 2 years.
Yeah,
so
right.
Just celebrated my 2-year anniversary.
Yeah.
My background is in manufacturing, contract manufacturing. So I've been doing manufacturing for over 30 years, believe it or not.
Yeah.
Straight out of high school. But I've been connected to actually a supplier of Leupold. All the metal that comes to Leupold is actually from a company I used to work with.
Nice.
And for them, I actually manage a lot of the automotive programs. So a couple you might have heard of, like Tesla and Ford. And
You might have heard Tesla, Ford, and stuff like that, right?
So those are fun. So we're bringing a lot of those concepts inside.
Yeah.
We have a new quality manager, Scott Puglisi. He's also got some background in automotive, so we're really trying to change our quality systems and the quality methods we have, and we're making some great improvements.
Yeah, well, talk about improvements. I was talking to Bill a little bit beforehand, and I just want to give him props where props are due. We've changed kind of how the shop floor functions and really squeezed out a lot of efficiency. I tell people this when we come through for tours. We're landlocked. We can't expand anymore on the piece of property we have. So the space we have is the space we have. And you've done a phenomenal job of getting rid of dead space and making every little single square foot efficient to do what it needs to do, right? Speaking of, you guys can't see it, but right over there's a big open area because we got 2 more machines that are going to be put over there, which is really exciting, right?
Yeah,
you said one just landed in L.A.
I definitely can't take all the credit. I may have the ideas, but the execution is completely not mine, right?
No.
Great group of engineering group, the value engineering team. It's a big collective effort for all of us, and how do we get these machines in here and spec the right machines. We're changing the way we've made parts historically with embracing new technology, which we'll get more in detail to. So I look forward to talking about it.
Excited to talk about that. But first I want to talk about a little bit about the history, right? So we've been making scopes since the mid-'40s. We had a shop in Portland. The scope side started to take off. We needed to build a new shop, and we came out here to Beaverton at the time. But this has changed drastically over those years, right? And I tell people, again, back to the tours, I tell people you're going to get lost in here because it kind of winds, and we've just kind of added buildings on here and there. How many square feet are we up to now of shop floor space here?
We are 160,000 square feet of administrative and manufacturing offices here.
That's insane. That's a lot of square footage. That's a lot of machine. And when you walk through here, it looks like this. It's machine. There's not space in between these machines.
We have about 4 different rooms, I would say, as we've expanded, where we've just packed in machines and keep growing. So
that's awesome. So go down the numbers here. You put some numbers here. How many CNC machines and parts turning machines and all that kind of stuff?
So in the building we have about 70 machines in total. Not all of them are dedicated production. Some of them are very high precision machines for making tooling or grinding tooling.
Okay.
But we have, in the parts side, we have 49 turning machines of different complexity and going after a specific function.
Right.
What we see behind us right here is a bunch of multi-spindles.
Okay.
The beauty of these are high-speed production machines. They have actually 6 turning spindles
Yeah.
that index like a machine gun turret kind of thing. So
Right.
An old Gatling gun kind of
You're
goes
right.
around.
A lot of people come in, if they've gone through like an ammunition factory or something like that, it's that same kind of turret style where it's turning and just it's really great for like adjustment caps and CDS dials and parts of the erector system, round parts, stuff like that, stuff like this.
Yeah,
I think
absolutely.
that comes off the machine right
these
there,
are
right?
These are actually multi-spindle parts, these little erector cells.
Yep.
We also have the Freedom pivot tubes that actually come off the MSs as well. Eyepieces come off the MSs, and a variety of different lower tolerance parts. I'd say lower tolerance for a reason.
Yeah.
We've got some Swiss screw machines that we actually are doing ultra precision, which we'll talk about in a minute. But they're dedicated to the small heart of the engine of the the erector system,
of the
right?
scope and the erector
so
system.
those are really dedicated to ultra forward tolerance precision.
Nice. So speaking of, I want to throw to a video real quick. It's only going to be on Facebook, not going to be on Instagram. Oh, can we go to the video? Okay, cool.
In the actual quality control function. Yep.
Oh.
Come back, Sinbad.
Oh, no, it's not working? It's not working? Okay, we're back. Yeah, it's not working. Sorry. We tried to throw through a video. Doing a live production here on the shop floor, had some issues, and we can't do that. Anyways, we were talking about how many people we have in our QC department. You mentioned that basically everyone is responsible for QC in some shape or manner.
Correct.
Right?
So as a machinist make their parts, they are responsible for a QC interval.
Yeah.
And then we have a quality control department that comes around and audits and makes sure that we're doing our checks.
Right.
The quality department's responsible for calibration, making sure all of our gauging. We've got some examples here we can talk about.
Right.
But they're responsible for making sure that our systems are in check.
Yeah.
And so we also have quality engineers, we have quality assurance people, but we're also looking at process capability studies and gauge reliability, repeatability studies. So making sure that the numbers we get are given the right information back to the machinist to make the best parts.
Gotcha. So that communication loop is there to make sure that we're making the best parts available.
But they're engaged in daily operations constantly.
Right. Yeah. I'm always impressed when I walk up to a machine and looking at it, the number of gauges and checks and stuff like that that's happening at the machine level on top of a certain number of those parts going into the QA or QC department to get looked at closer.
And we've got parts like these are thread gauges where we have actually 10 and 14 thread starts, which is unheard of. You just don't buy screws that are for that, and we're specially designed by our team. And so these actually are checked 100% as they come off the machines to make sure that everything is functioning within the spec limits of go and no-go. So we will actually thread those in 100% on the main tubes as they come off the machines and make sure that everything is at the quality level we need.
That's a really important fact there. And I talk about how important the threads are because the scopes are basically threaded together. And this is one of the things I always tout is that we use the minimal amount of adhesive and glue inside this scope. This scope is basically all mechanically threaded together, and that enables us to take the scopes apart, work on them, put them back together, and ensures the longevity of the scope. Because the issue with adhesives and glues and stuff like that is they're always going to be hardening and they're going to become brittle at some point in time and probably going to fail. Whereas a mechanically threaded together device like this is built to last many, many lifetimes. So, but
it's impossible to make a perfect part. I'll tell you that right now.
Right.
Statistically, it's impossible to make the same part every time, the same time. But there's a range around that. So it's good it's threaded because we can actually put in adjustments that we need, and we can actually repair it or fix it if there's problems. So.
Right. Exactly. Yeah. But again, those thread pitches become very, very important. I know you guys have. I forget what the site says, $1 million worth of like thread gauges in there.
Easily.
It gets expensive. And talking about the tooling and stuff, we actually have. We're going to talk a little bit about the departments down here too. We actually have a tool room, so we're making scope parts, but we're also making the tooling to go into the scope part. So
some of our functional groups that help us out is the tooling department. We physically have. A full-on tool and grind department. Somebody's giving us no.
So someone's waving us down. Oh, did we have an issue there on Instagram?
Yeah.
All right. the guy in the tool crib like pointed it out and fixed it. So let's see. Oh, there we go.
Perfect. Okay. So starting back over, so we do have a tool engineering department, and in that department they design tools like the inspection gauges, our thread gauges, things of that nature, and then through our internal network and also our suppliers, we'll actually make those tools to our prints. These fixtures that we do in the grind room, we're talking 5-6 decimal places of precision in that room, and that's making our carbide end cutters and doing also the process equipment that we need as well too.
Yeah.
Specific tool holders and designs. This is the magic behind the madness, is literally that competency that the engineering group has to get these machines, which anybody can buy, to do what we need functionally.
Right.
So that's the secret right there.
That's the special stuff. Yep. And someone asked a question. I forget who it was. Let me see if I can find that question real quick. Let's see. I don't know where it was, but someone asked, how come more optics aren't made in America, right? And how come more companies don't have a big facility like this making scopes? It's because of that secret proprietary stuff like that.
It is.
Anyone can buy these machines. Anyone can set up a shop, but it's that craftsmanship and that knowledge and that know-how. There's so much stuff that goes into it. It's kind of mind-blowing.
But the first scope was made in 1947, and the development and the ingenuity that kept them going forward.
Yeah.
I mean, they've got decades to have to catch up on that we've learned from, right? So
I was like, go ahead and do it. Yeah. We gotta scoot this way. I keep floating. I keep floating this way. So yeah. So that's a great point. Just and we're kind of control freaks with it. And I always say that in a positive light, because we like to control as many processes as possible down here on the shop floor in order to get that product that's going to perform for a lifetime, right?
Yeah, that control comes from pride. I mean, these guys have a lot of pride in what they do, and they're very committed to this.
Yeah, there was another question. It was how many people down here shoot and hunt? I forget who asked that, but that's a great question. And a lot of these guys do, and girls do. They not only work on the machines, making the parts, but they use the end product. And they get really excited. Someone said, do we get time off for hunting season? Yeah, hunting season, there are more FTO requests put in, definitely.
Flexible time off.
Yeah, flexible time off requests put in, definitely. Yep. So not only, everyone, 450 people down here on the shop floor, obviously not everyone's going to shoot or hunt, but a large majority of them do. And that, again, the pride that goes into the finished product. That American flag hanging in the background there, that's not just for show. People come down here and they talk to the machine operators and stuff, and you really get a sense of the pride that goes into these products, right?
We're an optics company, so we've got a lot of people that do bird watching.
Yeah.
Right?
Yeah,
there's other functions outdoors, because we're in the Great Northwest, so there's a lot of activities that use our product.
Yep. Let's see. Let's tackle some questions. Oh, where's Old Nick? That's funny. You guys voted on Instagram last night. You wanted Old Nick instead of Young Nick. I kind of am Old Nick. I got a lot of gray hairs and stuff going on, so I don't think the filter wasn't too far off from the actual guy. Let's see. MG Sights, is the Devo still available? Yes, we still have the Devo. If you guys haven't checked out a Devo, go check it out. It's we introduced it a couple years ago. Pretty revolutionary. You got to get behind one and try it to really appreciate it. That's all I'll say about that. Orinoco, why are all your scopes black? Blue, silver, gold, bronze would be cool. It's 2019, and we need variety. There we go. So yes, all the production scopes are matte black now. We kind of got rid of our gloss scopes. We made gloss for a number of years. It was just a numbers thing. People
we still can.
Yeah, exactly.
Just do the custom shop.
Yep. So that's what I was getting to. In the custom shop, we can do custom colors. So if you wanted a pink scope, a bronze scope, a gold scope, we can do that in the custom shop.
Distressed American flag.
They
do some crazy stuff.
Yeah, we started doing that the Cerakote on the scopes now, straight from the factory, and we got some really cool scopes there. So let's see. Let's see. Oh, here we go. Carjack, where are your components for your scopes made? That's a good question that I get all the time. they're made right here, right? This is why we have 160,000 square feet of, yeah. So,
we made over 11 million parts last year.
11 million parts?
Out of this factory.
Whew. That tells you, and I don't know if you guys can see, here's we have this cutaway of this Mark V right there. I kind of show it up there. Let's see if Scott can zoom in on that. But that'll kind of give you an idea of the number of parts that go into a scope, right?
Yep.
And, yeah, 11 million of that type of part. There's a lot of misconceptions out there. A lot of people think that, okay, we make the main tubes and maybe we import all the rest of the internal parts, but that's just not the case, right?
No, not at all.
Yeah.
No, we produce all the parts that we can inside, every part.
Yeah. And again, that goes into the performance of the scope and not trusting someone that they made a part right? We're going to make it in the shop. We're going to make it right. And, yeah, if one little part here is out of spec, then, you're going to have issues with the scope.
Yeah, I mean, we even like the pivot tubes, right? We get a little cutaway section of the pivot tube here.
Mm-hmm.
This actually is machined in-house, and this is 4 decimal place precision. We can't send this outside and control it to the level that we really need for functionality.
So I want to talk about that a little bit, about the tolerances. You said 4 decimal places. What does that mean for maybe someone out there who's not an engineer or, something like that?
Yeah, it is literally what we're talking about is controlling tolerances to 1/5 the size of a human hair.
That's
1/5.
That's insane.
Yeah, I mean, you can't see the amount that we're trying to control. I mean, it's that precise.
Yeah. What's that, Scott? Oh, to the slide?
Yeah.
Yeah, you can go to the slide. Yeah. So, a couple seconds here and then good. So, yep, back on Facebook there. Cool. So, you guys got to see a little bit of it's a cool visual representation of what that actually means, a fifth of a human hair.
Yeah, so
right?
that big green dot that you saw, that's the size of human hair, and that little blue dot that was the second smallest in there, that is the tolerance range that we're trying to control.
Yeah, because, I mean, these are rifle scopes, but they're precision optical instruments. Yeah. And if anything's out of spec in there, you're going to have weird issues going on. So that's crazy that you guys can hold those tolerances down here on the shop floor.
Hold is a strong term. So it is a continual battle of process improvement between the quality team and the engineering team.
Yeah, and
we test these machines to what they're capable of, and repeatability. And so we're taking coordinate measuring machines, CMMs, that actually can measure that tolerance to give us the data and the output so we can actually verify we're getting what the engineering team wants.
And we were talking about new machines coming in, and we have a ton of Index machines. Index is a German brand. They're kind of the Rolls-Royce of CNC machines. But we were talking about right machine for the right job.
Right part, right machine, right process.
Right,
exactly.
So we have some new machines that we just put in that we're talking about, 5 Citizen machines, right?
5 little Citizens, yep.
What is a Citizen machine?
It's a different process in the way the material is introduced through the spindle.
Okay.
And it's a smaller working envelope, so you have a little bit more control.
Okay.
And it actually precision up to the 4 decimal places that we're needing
to
really control repeatability and that statistical mention I made earlier, that make sure that part is within the tolerance range that we're needing every time.
Yeah. So, and if you walk over there, you would see a bunch of, mainly I see adjustment screws coming out of there.
Yep.
And those
erector cells for the higher end product.
Right, erector cells, stuff that has really tight tolerances on the threads, that you need really precise thread pitches on there to make sure those adjustments are tracking correctly. So it's always awesome to see those improvements on the shop and getting the. And
we're actually taking the CMM machines and putting them in conjunction with production, so we actually get that feedback real time back to the operators. So when they need to make adjustments because of tool wear or any kind of process change, they have accurate data, so they're not chasing the tails.
That's really smart too, because you wouldn't want to make a bunch of parts that are maybe out of print and then find out later. You guys you're testing them right there on the shop floor, and so the waste goes down. And like you said, there's nothing such thing as a perfect part, and sometimes stuff goes wrong. We make bad parts. People are humans, right? But it's about putting those processes in place to catch that, and then corrective actions to make sure that doesn't
there's
happen
a thing
again.
called inspector error. So even the same inspector can come up with different results using this traditional calipers or mic gauges or things of that nature just with force. So we've got to go to different methods in order to get that tolerance precision we need.
Huh. Yeah. Oh, that's awesome. I'm learning stuff today too. This is cool. Let's see. We're going to jump into some questions here. Becky Yackley, thanks Becky for sending a question. How does the manufacturing of first focal plane differ from the second focal plane? I'd say down here on the shop floor, probably not too much as far as making the parts, but in the assembly process, I know there's much different stuff going on for first focal plane versus second focal plane. When you put that reticle up front, there's different angles and different movements, and there's other things that are more difficult to assemble correctly and collimate correctly, meaning the focus and get everything in line. So that kind of comes from the cost increase on that. Plus the reticle itself is much, much smaller than a rear focal, and every time you shrink something like that, then the cost goes up as well. So.
Yeah, to just cap off on that.
Yeah.
For us, we have a print, so we don't know where the parts go into, and it's been pretty interesting as we're setting up here on the floor. How many of the operators are coming by and going, "Oh, that's the part I make. That's cool."
Yeah.
So it's fun to see the reaction we're getting on the floor right now. But we have a print, right? And the engineering gives us a print, a limits, and we actually then go off those limits, and we got to make it to print. So
right, exactly.
We don't always get to see where it goes. So
right. Yeah, that's to Bill's point. We had this cutaway down here, and before when we were setting up, a bunch of the machine operators and people walking by and being like, "Oh yeah, that's cool to see." For them, it's awesome to see an internal cutaway of the parts that they're making, right?
Yeah.
So
they're typically standing in front of a machine, so they don't get away too often.
Right. They're not chained to the machine or anything. Don't worry about that. Yeah. Smith Rhino wants to know, how are main tubes manufactured? That's kind of an interesting, a one-piece main tube. This is a pretty complex part to come out in one piece, right? How do you guys achieve something like that?
It's funny. We made almost 425,000 main tubes last year alone. And we made it in two ways. There's one that's the two-piece main tube.
Right.
So we actually have the ball and tube, and the objective end is different.
Okay.
And then we have the one-piece main tube. The one-piece main tube and the two-piece main tube start with what we call an impact blank, where we take a little bit of aluminum extrusion, we put it through a die, and it gives us almost a net-shaped part that we actually can machine from. And what that does is save material.
Okay.
So we don't remove so much material.
Again,
we have
efficiency, right?
Efficiency gains, right?
Yeah.
Also gives us a little metallurgical gain, too, where we actually get consistency and metallurgy, too. So a little bit better. We can speed up the machines. We get a little some efficiency out of it, which means lower cost.
Yeah.
The other thing we do is we also have longer extrusion bars, right? And we'll actually machine a full main tube out of a bar.
Yeah.
And that's what traditionally old turning CNCs were from, is all bar machines.
Right.
And so we're getting into automation and embracing some newer technologies of impact blanks.
I see that row. We have a row back there of machines that are the older ones, right? They're single spindle, and they're using that bar stock method. But then these newer machines here are using a different method, much more efficient. They're dual spindle, right?
They hold more cutting tools. They're faster speeds.
Right.
The technology's improved, so the processing speed's better, just like in the network or your phones.
Yeah.
So they just get faster and faster and better and more reliable.
Yeah, that's awesome. Yeah, so the main tube is definitely one of the big things. Like, we wouldn't let anyone else make our main tubes for us or do anything like that. This is very special to what we do. A lot of proprietary stuff goes into that.
Yeah, and I don't know if everybody gets to see that opportunity, but there's actually optical reflection grooves that's pretty key, and those are actually what's functional design into the scope, right?
Right.
Which actually reflects light, or blocks light, I guess is the right term.
Yeah.
And so not just the threads or positions of the holes or the slots for the erector system, but all of what's required for literally light control.
Correct, yeah, and you can see in this scope they're in a different space, right, a different area, and depending on the objective bell, is it short, is it really steep, these are going to be spaced further apart or closer together or a different pitch, and that's where the optical engineers come up with this stuff, right, and to really maximize what we're doing inside the scope to mitigate glare. And glare is going to wash out your image. It's going to make the image seem less bright. And that's kind of what Leupold's known for, is our image quality and how bright that image is. And that comes from a lot of hard work and dedication up from the optics lab down here to the shop floor, making it a reality on the parts and having those two teams working together, right, which is really cool. That's the other cool thing, too. You mentioned 450 people down here. We have 700 plus people, total in the building, but we're all in one building. which is kind of cool, right? You don't see that too much anymore.
We talk about control and process variants and things of that nature, and not everything's always perfect.
Yeah.
So if we ever need engineering support, they're literally just right upstairs from us and just come down and help us out.
Right. Oh, here's Scott sent me a reminder. You mentioned how many parts or main tubes we made last year, and we set a new record for the number of scopes being made last year.
We did.
And again, that goes to the team down here, the efficiency, making the right part at the right time and making it right, getting it into assembly, and that's pretty impressive.
It was a huge effort by everyone here.
Right. Hold on, getting a production note. We'll be right back on Instagram. We need to switch to the phone. Apparently, the iPad there is not working so well. So, Facebook, bear with us. These are the things that happen when you're down here on the shop floor live, right? So, set up to make scope parts, not set up to have us do video production. So, bear with us 1 second. I think he's getting the phone set back up here, trying to figure out. He may have to handhold it there. Let's see.
Test the steady skills.
Yeah. How good of a tripod are you, Scott? All right. So we're back on Instagram. Sorry about that. The iPad died or something went bad with the iPad. So let's get into some more questions here. These are cool. So Tech Coyote wants to know, how do you fill the scope and purge out the oxygen? So that's one thing that is kind of proprietary to Leupold. We do it a little different way than a lot of, actually every other scope manufacturer does it. Some scope manufacturers will just take the eyepiece off and they'll put the scope in a gas-rich chamber, let the gas seep in, put the eyepiece on, call it good. On the bottom of the scope is actually a fill plug hole right there. And we're actually vacuuming out the oxygen and then filling the scope with about, I think it's about 10 psi worth of the gas, argon krypton mix or nitrogen, depending on the scope. And pressurizing the inside really helps seal the gas in there. We press a little ball in there so nothing gets out. And it also helps with the shockproofness of the scope, too, doing it that way. So that's one of those little things that you learn over the years, scope manufacturing, different ways to do stuff, trying stuff, and makes the difference.
Leupold Stevens was the first to do it in 1945, right?
I think so. Yeah, exactly.
Yeah.
Yeah. So we're the first to do a lot of stuff, including that. So this is a good one. Brody Tachik Hunting. What is the most complicated scope? From a manufacturing process, I guess you guys, again, you're just making prints, or you're just making parts to the print, right? What's one of the most complicated parts, though?
I think for us, as we start talking tolerances and we start talking longer distance, the guys that are trying to shoot, way out there, right?
Right.
That means that we have to get more precise.
Uh-huh.
And so when we start looking at the long-range scopes, even the surface roughness in these, which looks like a mirror finish, that may not be good enough, and really when you measure it.
Mm-hmm.
So we've got to keep pushing the envelope, particularly as we start to get further out and you start looking at that triangulation of tolerance control, right? So that's where the engineering team is really trying to take that. We talk about the accuracy percentage, out far. Well, the further you go, that translates into even more precision on the inside of the scope.
Gotcha.
So it's really, for us, it could be a variety of models, I think. I don't know that answer to be exact, but that's the way I look at it.
Yeah, I would say that, this cutaway right here, this is a Mark V HD. Just visually looking at it, that's probably one of the most complicated scopes I think we make. It's got a lot of parts. Your 5 HD or your VX 5 HD, VX 6 HD, rotate them. Is that good right there? Anything with high magnification like that is going to be much more complicated. This one has illumination and side focus. You start adding in features like that, again, the complexity of the scope goes up for sure. So.
Yeah, for us on the manufacturing side, what really becomes I guess the challenge overall is to be able to service all the different customers for the different products we have and all the different, preferences and flavors that we have of scopes, right?
Yeah.
Making sure that we all have it available when they need it is really the challenge.
Nate's Adventure, he wants to know, how is the glass quality made higher and lower in the difference? So that's one of the things that we don't manufacture here is the glass. We're pretty open about that. There's not a domestic supplier that can produce glass, and you can't just start making glass, right? There's only so many companies in the world that can produce that glass. What we do have is a world-class optics lab upstairs where they're coming up with those prescriptions, those coatings and stuff like that. And again, that's the proprietary secret sauce that makes up those lenses that gives us the edge. The difference, there's going to be a difference from a VX Freedom all the way up to a VX6 HD, right? But you're going to see increased, as you go up in the line, you're going to see increased low light performance, contrast, clarity, that kind of stuff. The cool thing I think about, and someone had asked this earlier, talking about the product lines and stuff, they talk to you skimp on the manufacturing process on the lower end stuff versus the higher end stuff, and that's totally not the case, right?
No, there's no skimping. It comes back to the print and the functionality of the tolerance, right? What do we really need to achieve for the engineering spec to get the functional tolerance that are asking for?
Right. And so, talking about the VX Freedom scope, there's just a lot of shared parts there, and the volumes are a lot higher. So we can make those more affordable. They're tested to the same standards as your high-end scopes, your Mark V HD, VX6 HD, whatever it is. So our QC and our impact testing and stuff like that, doesn't matter where in the line it is, it's always going to be the same. So that's a great point right there.
Now we look at different technologies, I think, on the Freedom where, we're looking at a elevation adjustment knob, and we'll make that out of plastic injection molding to reduce cost, as opposed to, like the Mark V here. This one is, it's got a lot of functions because we go through different rotations and locks. Yeah. And so it's got a lot more functionality in it.
Let's see, Sinister 17, you sent us a bunch of questions. Thanks for that. Do you perform any lot destruction testing? Test scopes to the limit, ultimate loads. So obviously we do, because we take some main tubes, right, and cut them down the middle. Yep. So we are destroying some parts too in order to make sure that the quality is there.
Same with the mounts, same with the scopes. Everything has to meet the tolerances, functional requirements by the engineering spec, and so we test it. Because that's how do you know if you don't test it?
Right, exactly.
You got to prove it. So.
And that's completed scopes as well. They'll take completed scopes and put them on our Punisher, which is our impact tester that we have, and really put them to their limits and make sure that they're meeting that spec. So.
And then that testing is done and actually inspected at different intervals to make sure that it's not got some problem. We can find it where at through the test run.
Through the process, right? Because there are so many processes that go into making the scope from the raw material all the way to the finished. If you didn't have those QC checks in place, it would be really hard to backtrack and find where.
I remember when Bruce Pettit said that moment of truth when he pulled that trigger. It's got to be right.
Right.
It's got to be American made.
So what CNCs do you use? Clever SN wants to know that. I mentioned Index. We mentioned Citizen. I know we have Hawes too.
We're back to the right part, right machine, right process, right? We have horizontals, CNCs where the actual spindle is introduced horizontally instead of traditional milling. Okay. So we have horizontal mills, vertical mills. We have DMG Mori. We have Hawes. We've got wire EDM machines in the tool room. We got an Anka grinder. We don't shy away from a particular model. We're looking for the right solution, and also it meets the tolerance capability, but really total cost of ownership. Yeah. Right. So it may just have the best cycle time, but what's the uptime and repair parts and support service and all those things come into that question to where, at the end of the day, we're trying to make sure we get a more economical, feasible part cost so we can actually offer that off to our customers.
Yeah, which is important because, that's one thing people are always like, well, why do Leupold scopes cost so much? It costs this much because we have this level of domestic manufacturing here. It's just a fact that it's more expensive to manufacture stuff in the U.S., but it's very important to us, and it's something that we're not going to budge on, and that's just where the cost comes from,
and we stand behind it.
Yeah, but you're paying for the performance of the scope, and that's something we stand behind for sure. There's something I was going to mention there. I lost my train of thought. It was going to be good, too. Let's see. That was it. And one thing I geek out on too. We have a lot of these CNC machines, these high tech things. I kind of geek on the older machines too. Like in the grinding room, they got some old, completely manual vertical grinding machines. I know there's some hardage lathes out there in one of the tool rooms, some bridge ports and stuff like that. Yeah. For you machinists out there,
we have it all. I mean, we have even the old traditional lathes and stuff.
Yep. Let's see. Let's see. Oh, I think this guy must be he must be a machinist or something like that. What are some of the positional flatness, complanarity, I'm saying that, tolerances you guys work with?
Definitely a guy from manufacturing.
Right, yeah. He must. I'm just a dumb marketing guy, so I don't know what any of that means.
So we actually embrace all of the GD&T. So our prints actually have geometric tolerancing and dimensioning on it. So what we're looking for is really a form, fit, or function. So, just in the example of some of these gauges over here where we actually have a full functional model, we're checking that 3D form.
Okay.
And so to his point, we're verifying, we're verifying, that it actually fits together. So when the mating parts go together, they're in the right location, the right size, right plane. All of those things come into play.
Right.
So, and that's the beauty of a CMM, right? An engineer will actually say, my critical plane is the center of the tube, and everything needs to be dimensioned off the center of the tube. And so when we do a CMM, you can't do that with traditional inspections, right? With a caliper, because all you get is diameter. You don't get all the other functions of, roundness or, ovality or things of that nature. So really for us, it's actually creating that plane, which only can be done on a CMM. So that's the key of it is. And so to his point, we look at all of those things.
Okay,
yeah,
cool.
Every bit of it, engineering team and production team, and the quality team.
Easy Dow, why is Nick so hot? Thanks, Easy Dow.
I can't answer that question.
Appreciate you. Jerry, too. Jerry, if you're watching, I was going to give you a shout out too, Jerry PK. Let's see. Stan Bradley, how do you make your glass and scopes fog-proof and shock-proof? The shock-proof, I mean, going back to the impact tester, we put these things through hell. And it's actually pretty, it's kind of a marvel, a feat of engineering that we're able to produce something with all these small, tiny parts, glass, thread them together, and they survive this very violent thing that's happening when it goes on a gun, right? So I think that just speaks to the level of engineering down here on the shop floor that we do make stuff. And again, how do we do that? It goes back to the start, right? Making those parts super accurate down here on the shop floor. Dominic Sanino, is everything you sell made in America? So that's a question we get a lot. So if it goes on a rifle, it comes out of the factory here. We do import some binoculars, we import some rangefinders, some spotting scopes, some observation type stuff. But if it goes on a gun, it comes out of the factory here. But we're always looking at other opportunities to bring stuff back over. That's is important to us, that domestic manufacturing. So, but yeah. All the scopes are made here. So.
Yeah, and the mounts too. The mounts are made right here in the factory.
Sorry,
so,
I keep forgetting the mounts.
Yeah, and we do have local partners that help make mount parts or even some of our mounts for us, right? So, but we really embrace the American ingenuity and spirit here for us to really offer
that's
good American-made product.
That's a good question too that I get a lot. Maybe you can speak to it a little bit. But some of the stuff we do get, like the erector springs and some of the O-rings and screws like that. But we partner kind of with some local supplier. We try to keep everything as local as possible, it seems.
It's just keep that supply chain footprint small.
Right.
Because that way we get better support, we get better service. Lead times are shorter because we can actually respond to different variety of product being made.
Yeah.
So it all comes together in supply chain management.
That's very good. Sooner Oregon, he was the one who asked why other scope brands can't be made in the USA. I think we're kind of covering that this whole show here. Here we go. Ryan Barbu, how do you choose which supplier to go with when we're talking about sourcing a screw or something like that? Yeah.
It's the engineering team and the purchasing team collectively that really make those decisions. But it really is performance and history. We have a lot of long-term existing suppliers. So, we embrace that partnership that we have with those supply chains. Yeah,
and I know they're vetted and checked out very thoroughly before we start bringing parts in.
And it's not just price.
Yeah.
It's all the whole package that we get.
For sure, yeah. Again, we're not going to skimp on quality. If the price is the price.
Yeah, and they get prints from us, so they still have to adhere to the requirements that we set forth.
Yep. Let's see. We talked about that. Trying to find some good questions here. Here we go. Clever SN. How many CNC steps or tools or setups are involved in producing a scope? Geez, I guess it depends on the model of scope, right? But I can't even kind of fathom how many there are.
It's a lot. You know, we actually look at our machines with the number of spindles we have, number of turrets we have, how many stations we have. We do a lot of what we call sister tooling. So actually in a traditional turning center with the turret, we'll actually double up tools. And what we're trying to do is actually reduce the amount of setup time we have in the machines so we get more productivity off of the machines.
Yeah.
And that also helps control quality as well, too, because the less amount of times we're in the machine actually making adjustments or tweaks, let the machine run. They're thermally stable. They're actually outputting better and more consistent. So we're actually trying to do that with lean methodologies, right? Making common setup configurations and turrets. So therefore, maybe a simple bar change and a program change, and do our first article and
Gotcha.
QC checks, and away we go. We're in production. So
yeah, that's something I mentioned when I bring people down here is that the machines are in families, right? So they're going to kind of run like parts to minimize the setup time, right?
Yep.
Because the setup time in a machine can take a really long time, right? If you were setting up a machine from scratch to get it into production, how many hours could that take? A couple shifts to get?
And the machinists become familiar with those parts. They're intimate with the quality and the functional requirements, and they know what needs to be done for those parts to make sure that we get good output.
That makes sense.
We take feedback from the assembly group, from the engineering group, from the quality group. We review the parts with the people on the floor and actually talk about, improvements that can be made and engage the programmers and engineering team to actually make improvements, keep tweaking it, making it better.
Right. Talking about some of the other departments down here too, I think over on this side we have our hazmat department. So we have a whole department too that's kind of responsible for recouping all those materials and stuff coming off the machines, right? All the aluminum, the steel from the mounts and rings, mostly aluminum, right? We use a ton of aluminum.
We recycle it all.
Yeah. So that's one of the cool things. We got a machine over there. It actually takes all the aluminum chips, right, and sandwiches it down into like a soup can kind of shape,
it
right?
Pulls all the coolant and oils off of it and centrifuges it and then packs it into a small puck. So therefore, when the cast house goes to remelt that aluminum back into more raw material, it physically does melt quicker and faster, and and also we get a better scrap rate out of it too. So win-win, right? So,
efficiency, and that's the other cool thing is talking about sourcing and components and stuff. It's all domestic aluminum that we're using here, right? So we're not importing any aluminum. It's all American made into the American made scope. So I love that kind of stuff. Let's see other good questions here. Let's see. John Conti III, will you be bringing your thermal technology to scopes? People are always asking about that. They want some thermal scopes and stuff like that. We are always looking at at opportunities and new stuff. We're always evolving, and we got a R&D shop upstairs with technologists looking at stuff. We have the handheld thermals. If you haven't checked those out, those are really cool. The tracker, the LTO tracker.
LTO housing right here.
Yeah, the LTO housing right there. Yeah. So check those out. I know you guys wanted a weapons mounted one. The issue for us is trying to make it as durable, right, as it needs to be. Our testing processes are pretty stringent, and making sure that those electronics can fare, well through that impact testing. It's an ongoing process. So who knows? I don't know. We'll see. Let's see. Fred Schoen, do you plan to be at the first ever American Made in America show at Indianapolis? I'd never even heard of that.
Hadn't heard of it.
Yeah, that's an interesting one. That's a really cool idea though, that someone would have a show of just products just made in America, and that might be something we want to do. So, here we go. How long does it take to make a scope from start to finish? I always get that question down here on tours, and I never quite know how to answer it, right? Because there's so many variables, and it depends on a lot of stuff.
Yeah, there's a lot of different components and different lead times of everything that come together. We can actually have something from the parts side into assembly in a couple of weeks as we go through the anodizing process, the bead blasting, the finishing. So we're really trying to strategically predict what the customer is going to want, and have that sitting in front of assembly. So therefore, whatever the customers buy to fill our 20,000 square foot DC, we're literally, just weeks away from having it available for, what the customer's looking for.
I think the time has improved. I remember, I've been here 13 years. I remember when I first got here, I noticed on the shop floor or throughout the process, there was a lot of stop points where parts would get to a certain point and then they'd sit for a while. And then they'd get to another point and they'd sit for a while. Now it seems, correct me if I'm wrong, but just from my observations down here, that the parts are kind of flowing through all the processes pretty seamlessly, right? We got carts of parts going down the aisle right there. All the way to that finished component that goes in the component warehouse that sits for the work order to come down and sent into assembly and put into a scope, right?
Yep, our ex-Marine, by the way. So.
Oh yeah?
She was,
That's awesome. So, so a couple weeks for a part to get through, probably do the assembly time if it's going straight through into a scope.
Yeah, no, we're working in partnership with the planning team to really understand what is needed and driving the orders and continuously trying to get the material flowing through.
Yeah, and that rolls into this question. Are all the parts the same for each scope? And how do you decide how many parts to make for each scope? So obviously they're not the same for each scope.
Yeah,
right?
It's customer demand. I mean, you buy more, we'll make more. Right?
Yeah.
So that's what it comes down to.
And that's the best thing about making stuff right here is we can change that mix. If we see the market wants more of this and less of this, you guys can adjust down here on the shop floor and make those parts that we need. And it's great to have that flexibility, right?
Yeah, I mean, last year was crazy for us because we were trying to push a lot of new Freedom product out,
Yeah.
so it would be available for anyone who wanted it. So we're really pushing hard.
Yeah, it's proved to be a very, very popular line. I mean, a starting $200 American-made scope right here from Beaverton, Oregon. I mean, it's been really, really, really popular. I'm not even gonna Nana Quatch. I'm just butchering names over here. What is Punisher? What is the Punisher test? So I mentioned that a little bit earlier. That's our impact test. Without going too into it, and actually, eventually I do want to do a live, hopefully, from the impact test room. We're going to try to get the okay to do that to show you guys what it is. But basically, we have machines that can replicate what a rifle does when it shoots because G-forces aren't equal. Me hitting this pen is creating G-forces, but that's not the same as shooting a rifle, right? So we're actually taking the recoil trace off the rifle, exactly what it's doing, uploading it into the machine and replicating that. Baseline test, 5,000 impacts, 975 Gs. If you shot a rifle that could do that, and our crazy guy who runs the impact lab there did, you actually knock yourself unconscious each time you shoot it because it accelerates your brain so quick. You get a concussion, you get broken blood vessels. It's not a gun you'd want to shoot. It's based off a very lightweight safari caliber gun, but that's the baseline test, and that's for everything. That's all the way from the Freedom up to the Mark V HD. Everything has to go through that in order to go into production, and because we don't know what rifle you're going to put it on. You could put it on a 22, or you could put it on a big, safari caliber rifle. So who knows? So we got to test everything to that. Let's see. This is a good question. Shaq Jeffrey, is there a limit on how big of a main tube diameter can get on a rifle scope? I guess I don't know if there's a limit. I mean, that's probably for a design engineer to determine.
I would say, our bar size is 90 millimeters, so that's
you guys want
large.
You guys want a 90 millimeter main tube? We're gonna shoot out like 4 or 5 miles with that bad boy. I mean, there's probably going to get to a point where main tube size will probably stop growing. I know people talk about the Mark V HD, this scope right here. I know that's a 35 millimeter main tube, and there weren't a lot of 35 millimeter main tube scopes out before that. This is definitely the most popular one out there. But that goes to the internals, and I try to explain that. So inside here is the erector system, right? That's the tube within the tube that's moving around. And all a bigger main tube does is lets you have more adjustment inside the scope. It doesn't create more light or let more light into your eye or anything like that. All it is for adjustment. Though the little secret here is this erector system, the diameter of that. That's really the pinch point in the optical system that's letting light to your eye. And we could have gone with a smaller main tube and gotten the same amount of travel by decreasing the diameter of that erector system. But the issue with that is you decrease the quality of the image getting to your eye. We need that quality of the image to be at a certain caliber, and we're not going to decrease the diameter there. So in turn, increase the diameter of the main tube up 1 millimeter and to get the right amount of travel while still having that awesome image in the scope. It's marrying those two together and finding the sweet spot. So that's a really good question.
And we're also making sure we got mounts available. So as we have the main tube, we're also working diligently on making sure we have mounts to meet the different guns and the different sizes of main tubes.
Great point. We have a bunch of 35 millimeter mounts now, all the way from the Mark IV line to the backcountry line. I know we're even introducing some of you guys out there have asked for the medium 35 millimeter mounts. We'll have those soon. I know Pete, the product line manager, is working on that. For the Mark V H, he's going on a bolt gun that can sit down a little lower.
Yes.
So
I brought a backcountry ring mount for you, so you can actually see it too. So.
Yeah, that's awesome. So the machine that these are made on is really impressive. You touched
it's the horizontal,
Mori,
the Mori,
right?
DMG Mori. Yeah.
So they take extrusions, right?
Correct.
And they mount them up. You call them pallets, right?
Correct. Tombstones.
Tombstones. Yeah, they're big blocks, and you can put a bunch of these up there, and then stick it into the machine, and it goes around, and machines down the top and the sides of it, right?
Yeah. Beauty of that machine is literally you can put them in a row, and as you come down in your face and your landing area, you can literally just hit all the parts at the same time without a tool change. So you can get multiple parts off without having to tool change.
Again,
it gets very efficient.
Efficiency. Yeah. A lot of good questions coming in, guys. Thanks for putting these out there. The Vintage Vagabond, I like that name. How can you make the Freedom line in America and offer it at that price point? Well, from a manufacturing standpoint, I guess I'll let you touch on that a little bit.
It was a lot of work with the engineering team, right? As they are looking and working with our programming team and the value engineering team, coming together to really evaluate what functionality they need, don't need. Yeah. And like I mentioned before, we looked at plastic injection molding. So if it's not a critical part to the engine, we could actually put a lower cost part in there.
There you go.
And you still keep the functionality up there, but then we can reduce the price. And so this is a lot of engineering work to make these things happen. Yep. And beauty is with the volume, playing for a plastic injection mold, you can amortize that cost across, and the part cost itself becomes pennies compared to taking a bar stock and putting it in a traditional CNC.
That's a great point.
So it's really that engineering and supply chain partnership.
And the shared parts too. I think you guys probably noticed. Obviously, the VX1 and 2 got absorbed into the Freedom line. You'll see other scope lines get absorbed into the Freedom line. So as many shared parts as possible, if we can make higher volumes of those same parts, that helps you keep the cost down as well. So, Scott Favreau, how do you print reticles? What do they look like, and where do they go in a scope? That's a great question. So we actually don't do any of the reticle manufacturing in-house. Those are one of the source parts that go into a scope. We're looking at some different technologies. Maybe that'll change in the future. Who knows? But there's a couple different types. There's an electroform reticle, which is kind of comes on a sheet, and that pattern is stamped out. It's a physical metal reticle that gets glued into a housing. The drawback to that is that you are you can't have points in the reticle that are just sitting out there. It has to be connected, right? Because it's a physical metal reticle. Then we have glass reticles, right? Which are a little more, you can do more things pattern-wise. You can have that grid style that has a bunch of windage points out there because it is etched on glass. So a couple different ways that we do reticles here. We actually still do wire reticles too. It's a really cool process to see in assembly. It kind of looks like they're tying fishing lures or something like that, fly fishing. But they have this little jig and they make wire reticles, still do duplexes that way. As far as where reticle goes in a scope, so we have a finished erector system here. This is kind of the heart of the scope again, the tube within the main tube. And for a rear focal, your reticle is going to go back here. This one actually does have a reticle in it back here. Or for front focal, it's going to go back here. I like to explain, you'll notice in a rear focal scope, when you turn the magnification, the reticle doesn't change size. It stays the same. That's because in the optical system, you're seeing the reticle first, then the magnification is happening in these lens elements, then you're looking out the front of the scope. As opposed to a front focal scope where the reticle is up here. So you're looking actually through those magnification elements, then the reticle. That's why it looks like it shrinks and grows when you turn that magnification. So those are the differences and the different types of reticles that we have here. So let's see. Blair, can your scopes go on a pistol? Good question. Yeah, they can go on a pistol. We have Now we have pistol-specific scopes because when we're talking about eye relief, right? Eye relief is the distance from your eye to the scope. If you're shooting a pistol, that eye relief is a little different, right? We have what's called a extended eye relief scope, and that's, I think it's about 9.5 inches away. That's where the eye relief is. So when you're shooting a pistol, it's right there. There's a VX3i 2.5 to 8 by 32 that we make. A lot of guys use Smith & Wesson 500s, put them on that.
Delta points.
Delta points, yeah. For scope wise, we have some reflex sights too. So the Delta Point Pro is probably our most popular one that goes on a pistol. But if you're looking for scopes, we have those too. A couple of fixed power scopes too that'll go on a pistol. The cool thing too in that testing process, that they're tested to those specifications to hold up to pistol recoil. Also, the other question we get all the time is air rifle recoil. Will your scopes go on an air rifle? And all the scopes are rated to go on air rifles, which is kind of cool. Air rifles have a weird recoil signature, yeah. So, and that goes into our lifetime guarantee too. We're guaranteeing these products to last for a lifetime, independent of what you're going to put them on, air rifle, pistol, rifle, whatever it is. And if it happens to break for whatever reason, because stuff does break sometimes, that's why we have that warranty. Send it back, and we have that expertise in-house to fix the scopes. That repair department that we have is a lot of knowledge in there. The scope smiths in there are really talented, can take the scope apart, put it back together. If you have an issue with the scope a couple times, they'll even put it on an accurate rifle and shoot it and see, okay, is it the scope or is there something else in the system? So really great to have that product service repair department there. Let's see, one last question. Let's take this one. Have you expanded your CDS output? Are you still 60 to 90 days out? So CDS has been really popular. Our 6HD, 5HD, those three eyes come with CDS now, or they have for a while. Every CDS scope, you get one free dial, one free ballistically matched dial. And I think last year we had some issues, production issues with it taking a while. We fixed that. They got a couple new machines
Brand
down
new
there.
lasers, interface with the order system, so the order system drives automatically right down, so they're getting efficiency.
Right. We did a whole process change on that. They're running days now, maybe a week turnaround at the most.
The key in for the order the processing is the day before.
Yeah, right.
They're on track right now. Doing great.
So they're pumping them out. I hope you guys are seeing that, and big thanks to the custom shop team for getting that taken care of. They did a phenomenal job. I would recommend, though, sooner rather than later. Don't wait until your hunt is, a week, and then try to get a dial, especially into hunting season. The turnaround times will still be low, but they do bump up a little bit. So, if you can get out there and chrono your stuff sooner rather than later,
Just before we close, I do want to hit on a couple of points that, we're embracing the spirit of ingenuity that we have here.
Okay.
And really the technology that we're going after. Just as simple as in the custom shop, we've got now 5 3D printers. This is actually a mock of the QRW, and the reason we made this is just only for packaging audit. So we actually can make sure that the packaging that we were designing for it that actually worked and fit. So we're doing tooling, we're doing fixtures, we're doing simple assembly fixtures. We're really getting into new technologies, and so why I bring that 3D printing up is it's not just that. We're also looking at electrochemical machining. We're looking at lasering. We're looking at anything that will give our customers a better product and quicker.
Yeah.
So
I think that's super important. We're not resting on our laurels, just doing what we've always done.
Nope.
That American spirit of ingenuity is alive and well here down on the shop floor. So, Bill, I want to thank you for joining us.
Anytime, loved it.
Sharing a bunch of knowledge. I learned a lot, too. I hope you guys did. And until next time, we'll see you guys.
Thank you.